Good evening, Niharika. Niharika, are you getting my voice? Good evening, Samhita.
Good evening, sir.
Samhita, so what is the main important concept we are having in this chapter means here? Actually, we have a one important concept. So what is that means here? Periodic properties.
Sir, could you give me 1 second? I'll just get my charger and come back.
Okay, ma'am.
Yes, sir, I'm back.
Okay. Physics class, how many members they logged in?
Sir, only me, sir.
Only you are.
Yes,
What
sir.
happened? What about the remaining others?
I don't know, sir.
Okay, so just I'm in doubt, that's why I'm asking here. Actually, today onwards, they started the JEE slots, huh?
Yes, sir. Today is from JEE. Yeah, tomorrow my
Yeah.
start is on 9.
Yeah, some of our students are telling that JEE slots are started, sir, and all. Yeah. So that's why I got it out. If students are not attending these, so based on that one, we can expect here they maybe have JEE exam. Okay.
Yes, sir.
So I think so. We got very less time. Okay. So now briefly, I'm going to explain. I don't want to prolong this one classes here. Okay. I thought that I'm teaching like as a regular classes here. Okay. But I want to give the full content. So that's why I'm teaching a little bit depth. Okay, even that also I'm not considering this as a depth. In that also 80% I'm giving the content. 80% only I'm giving the content. Still 20% somewhere I'm leaving here. Because I want to complete more syllabus to you. Okay. Then when you are having slot
9, sir.
9. Okay. So hope so until that I'll try to finish as early as possible. I'll try to finish a little bit some more other chapters also. Okay. Right?
Yes, sir.
So here, periodic properties. So what is meant by the periodic properties, ma? So periodic properties is nothing but the properties which are repeated after regular interval of time is called as a periodic properties. Okay, like our class duration. Okay, so generally first period, second period, third period we are calling. So what is your class duration, Samita? What's your class duration?
Time, sir. 40 minutes.
40 minutes only, yeah?
Yes, sir.
In which college you are studying?
I usually 40 50 minutes or so. Silver Oaks.
Actually, so why I'm asking means here, Narayana Chaitanya people, they used to give us a 1 hour slot. Okay,
Okay.
1 hour, 15 minute slots are there. Okay, so that's why I'm asking here. Okay, so otherwise,
Yep.
other institutions are 40 minutes or 15 minutes only, they'll give the slots here. Okay, now in this one, we're
Yes.
telling that here, so period means we're telling that as a 40 minutes here. So after 40 minutes, every 40 minutes, it's going to be start as a new class only, na? Okay, so similarly, here also after regular interval of the time, the properties of the elements are repeated with that we can call as a periodic property. Okay, and here, what are the periodic properties we're having means one is atomic radius. One is atomic radius. Sir, what is mean by the atomic radius and how many types of the atomic radius we are having means here? First of all, what is mean by the atomic radius means first I'm going to draw the atom structure of atom. Every atom it has a nucleus. Electrons are revolving around the nucleus. Okay. Now atomic radius means it is the distance between the nucleus and outermost electron is called as here atomic radius. Okay. What is mean by the atomic radius? It is the distance between the nucleus and outermost electron in an atom is called as a atomic radius. Okay, so we cannot measure the atomic radius directly. How we are going to measure the atomic radius means here by X-ray diffraction method. By X-ray diffraction method. So by using the X-ray diffraction method, we are going to calculate the atomic radius. Sir, what are the units of the atomic radius? So what are the units means? Atomic radius can be represented in Armstrong units, nanometers, and picometers. Okay, you know the values of the Armstrong units, nanometers, and picometers also. So where we had seen means at the time of your wavelength. Okay, there I had given the clear the values. What are the value of the Armstrong unit in meters and centimeters and all? Clearly I had given. Okay, now how you are going to calculate the atomic radius means by X-ray diffraction method. It is not possible to calculate the exact value of the atomic radius. Okay, now so we have a three different types of the atomic radius are there. So one is called as a covalent radius. One is called as here covalent radius. Sir, what is mean by the covalent radius means the distance between, okay, for example, covalent bond. So covalent bond is nothing but it is a mutual sharing of electron between two atoms is called as a covalent bond. So this is a nucleus and this is also nucleus here. Okay, so these two atoms are held together by the covalent bond. So how we can define as a covalent radius means it is half of the internuclear distance. The total, the distance between two nucleus is called as a distance mark. Okay, so this we can call as a, it is half of the internuclear distance between two atoms which are held together by the covalent bond is called as a covalent radius. Sir, what is the covalent radius means? Covalent radius is nothing but it is the half of the internuclear distance between two atoms which are held together by the covalent bond is called as a covalent radius. Okay, another one it is there. And metallic bond or metallic radius. What is mean by the metallic radius means the distance here. This is the one metal atom. This is the another metal atom. Okay, the distance between the two nucleus. So this one also nucleus, this one also nucleus. The distance between two nucleus of two atoms is called as a distance. And how we can define as a radius? From here to here we can take as a r. From here to here we can take as a r. Okay, so generally we can write as a 2r is equal to d. Then what about the r? R is equal to d by 2 only now. So based on that one, how we can define? Okay, it is the half of the internuclear distance between two atoms which are held together by the metallic bond is called as a metallic radius. Okay, and van der Waals radius it is that. Okay, and van der Waals radius. Sir, what is meant by the van der Waals radius means here the distance between two atoms of two molecules which are held together by the van der Waals attraction forces is called as a van der Waals radius. Okay, it is half of the internuclear distance between two atoms of two different molecules which are held together by the van der Waals attraction forces is called as a van der Waals radius. Okay, to make you understand, I wrote as a diagrams in a different manner. Okay, so based on that one, let's see, we have a three types. So one is the van der Waals radius, it is there. Another one is covalent radius, metallic radius is there, and another one is covalent radius, it is there. If you compare with the van der Waals radius, metallic radius, and covalent radius, which one is having the greater the value? Van der Waals radius is having greater the value than that of the metallic radius. Metallic radius is having the greater the value than that of the covalent radius. Okay, so metallic radius and covalent radius, how much difference it will be there means here 20% it will be difference. The radius of the metallic and covalent is how much difference it is there, ma? 20% of the difference it will be there. Now you got the clarity, Samhita?
Yes, sir. Yes, sir.
Right. So next, so what are the properties in groups and periods? In groups and periods, how we are going to explain the atomic radius? Okay, so first we can take it out here. Down the group. Okay, down the group. So down the group, atomic radius is going to be increases. Down the group, atomic radius is going to be increases. Sir, how the down the group atomic radius is going to be increases? Why the down the group?
Because shielding effect is more and nuclear charge is less.
Atomic radius is going to be increases. Sir, why the atomic radius is going to be increases means last time we studied about the quantum numbers. What is mean the quantum numbers? Principal quantum number. There we studied one point. If n value is increases, size of the atom also is going to be increases na. That means atomic radius also is going to be increases na. What is mean by the n value? Energy level. Okay, if the energy level, that means how we can define means if the differentiating electron enters into the new energy level. If the differentiating electron enters into the new energy level means the size of the atom is going to be increased. So what is the example means? So we have a orbital. So this is the nucleus. Around the nucleus, if the electron is revolving here, okay, this we can call as a first orbit. The distance between the nucleus and first orbit, it is less or more? Less only now. That is considered it as a x. And another one I am going to draw here. Second energy level. Second energy level means the distance between the nucleus and outermost electron is called as a atomic radius. Now x and y it is there. X and y. So which one is having the greater the value? If you compare with the x and y, which one is having the greater the atomic radius? Samhita.
Sir, y will have the greater atomic radius.
Y is having the greater the value now. Okay, so y is having greater the value.
Down the group, the size increase, atomic radius. Down the period, atomic radius decreases, right?
Down the group, ma. Periods means which one? So groups are nothing but vertical columns, ma.
Yes, I know. I'm just saying that down the period, the atomic radius will decrease, right?
Yes, ma. So across the period we can call it here. Okay. So periods. Okay. Periods. If you take the periods means here across the period atomic radius is going to be decreases. Across the period atomic radius is decreases. Okay, that is only we can call as here from left to right, ma. Left to right atomic radius is going to be decreases. Why the atomic radius is going to be decreases means here due to effective nuclear charge is increases. If the effective nuclear charge is going to be increases means size is going to be decreases. Sir, what's the difference means here? Sir, what is the difference between the groups and periods? In groups periods means the differentiating electron enters into the same energy level only. Okay, the differentiating electron enters into the same energy level only. Okay, that means number of protons are increases. Number of protons are increases means nuclear attractions are going to be increases. That time it strongly attract the electrons which is present in the outermost orbital. Whenever it is strongly attracted means automatically size is going to be decreases. So due to that reason only across the period atomic radius are going to be decreased and down the group atomic radius are going to be increased. Here only I'll give the one more concept. So what is another concept means here? Ionic radius also is going to be increases. Ionic radius also it is going to be increases down the group. Okay, ionic radius is going to be here. Ionic radius it is having the variable mark, but ionic radius is going to be decreases across the period. Okay, so which one is going to be decreases here? Ionic radius also is going to be decreases. Okay, now let us see, sir, what is mean by the ionic radius? What is mean by the ionic radius? Let us see. What is mean by the ionic radius? Ionic radius. What is mean the ionic radius means? It is the distance between the nucleus and outermost electron in an ion. We have two types of the ions. What are the two types of the ions are there? One is called as a cation, another one is called as a anion. Which we can call as a cation. The positively charged ion is called as a cation. Positively charged. Which one we can call as an anion means here negatively charged ion. Negatively charged ion is called as a anion. Sir, how you get as a positive charge means by losing of electron. By losing of electron, you will get as a positive charge. Okay. By gaining of the electron, by gaining of electron, you will get as a negative charge. By losing of the electron, you will get as a positive charge. By gaining of the electron, you will get as a negative charge. Sir, what is the best example means here? Let us see bromine is there. So bromine is exhibit as a plus also. At the same time, bromine it exhibit as a minus also. Sir, when it exhibit as a plus means when the bromine is loses one electron, then we are going to represent as a plus. When the bromine is gains one electron, that time it can represent as a Br minus. Now you got the clarity. Sir, what is meant by the ionic radius means? The distance between the nucleus and outermost electron in an ion is called as a ionic radius. We have some questions. What is the questions are there means here? If you compare with the neutral atom, sodium is there. Na plus ion it is there.
Sir, I have a doubt.
Yeah, Mayam.
Sir, when does bromine gain a plus charge? For an example, because bromine is electronegative, right? So won't it
Right
be
now, bromine is electronegative only. So actually, bromine can be exist in a molecule na Br.
Yes, sir.
Br2. Okay. Whenever it undergoes to the unsymmetrical cleavage, unsymmetrical in the formation of the one bond total, how many electrons are required? Two electrons. Okay. That means one bromine is fully takes the electron.
Yes, sir.
That time it will get as a minus. Another one is it loses one electron. Na? That time it will get as a Br plus. Now you got the clarity. Samita, you got the clarity?
Yes, sir.
Okay. Now, my question is here sodium atom is there, sodium ion is there. So which one is having the greater the size? Either cation or anion. I had seen this question in previous years also. Ma. Previous years statement wise question I had seen in JEE only.
So could you repeat the question?
Sodium atom and sodium ion I had given. So which one
Yes.
is having greater the size?
Sodium atom.
Very good, ma'am. So atoms are neutral atoms are they having here greater the size. Sir, how you are telling that means neutral atoms are they containing 11 protons and 11 electrons. But ion, if you check it out, ma, how many protons are there? 11 protons, 10 electrons only. If you compare with the electrons and proton, more number of protons are there. Number of protons are increases. Effective nuclear charge is going to be increases. If the effective nuclear charge is going to be increases, means automatically size is going to be decreases. Automatically size is going to be decreases. So due to that is only Na plus ions are having lesser the size than that of the neutral atom. Okay, same one more question I'm asking here. For example, Cl neutral atom it is there and Cl minus it is there. So which one is having the greater the size? Either atom, ion. In the second case, in anion, Samita,
Ion, sir.
ion. So why it is having the greater the size means electrons are having repulsions. While having the repulsions, they occupy the more space. They occupy the more space means automatically size is going to be increased. So due to that reason, while comparing with the chlorine and chlorine minus is having greater the ionic radius. That means negative anions are having greater the size while comparing with the atom. Cations are having lesser the size while comparing with the neutral atom. Okay. Now, so whenever you get as a isoelectronic species, isoelectronic species. So what is the isoelectronic species?
Same number of electrons.
Very good. They contain the same number of electrons. Isoelectronic species. Okay. So the ions which are having same number of electrons. Well, having the same number of electron, the size is, how we can define the size means here, size is, positive charge is increases, size is going to be decreases. Okay, size is going to be decreases. If the negative charge is increases, size is increases. Size is going to be increases. Same why, what is the reason means here? What is the reason we can write as means here? ZEFF, effective nuclear charge. Effective nuclear charge is directly proportional to the positive charge on the cation. Positive charge on cation. Okay, and effective nuclear charge is inversely proportional to the negative charge on anion. Negative charge on anion. Got it?
Yes.
Okay. Now according to that one, now I'm giving us some different examples. So what is the example I'm giving means here? Na plus Mg plus 2, okay, and Al plus 3. So can you write the increasing order of ionic radius in a given ions? Increasing order.
Yes, sir. One second. Sir, Na, then Mg, then decreasing order. Sorry, increasing order will be Al, Mg, and Na.
Very good, ma. So increasing order means here. So here Al is the least one. After that magnesium. After that sodium. Okay. If the positive charge is going to be increases, size is going to be decreases. Okay. And one more question. What is another question means here in this only? So N3 minus. Okay. And O2 minus. F minus. Which one is having the greater the size?
Greater the size will be N3 minus.
Very good, ma'am. N3 minus is having the greater the size than the top. O2 minus, after that F minus. If you see means all are having equal electrons only. N3 minus also it contains the 10 electrons. O2 minus also it contains the 10 electrons. F minus also it contains here 10 electron. But which one is having the greater the size means N3 minus is having greater the size. So because of anion size and number of electrons are increases, the size also is going to be increases. For the clarity? Okay.
Yes, sir.
And one more question here. So before that, down the group, we gave one statement. Down the group, what happened here? The size is going to be increased. For that one, I'm taking as alkali metals. Li plus, Na plus, K plus, rubidium plus, cesium plus. Okay, so down the group, all are lithium, sodium, potassium, rubidium, cesium. Lithium, sodium, potassium, rubidium, cesium are belongs to which group, ma? They belongs to which group?
First group.
First group. Okay, so first group means down the group size is going to be increases or decreases?
Size is going to be increases.
Size is going to be increases. That means from lithium to, okay, from lithium to cesium, size is going to be increases. Okay, across the period now only we had seen. Okay, so what is across the period means here? For example, nitrogen, oxygen, fluorine is there. So all these are elements are present in the second period only now. Nitrogen, oxygen, fluorine are belongs to second period. Across the period, size is going to be decreases. Now we got the clarity. So this kind of questions they're asking the examination part. They'll give some examples. We have to write either increasing or decreasing order of the ionic radius. Now we got the clarity.
Yes, sir.
Right. Then we'll go for ionization enthalpy. We go for here ionization enthalpy. Ionization enthalpy. Ionization enthalpy. So this also we can call as the ionization potential. So what is meant by the ionization potential means here the minimum amount of energy is required to remove an electron from the neutral gaseous atom is called as a ionization potential. I am writing as an atom. Atom means here nucleus is there, electron it is there. Okay, so it is a neutral atom. It is a stable. So in stable atom here, if you want to remove the electron from the outermost orbital, okay, which one we have to do? We have to remove means here. We want to remove the electron from the outermost orbital. So to remove the electron means we need some energy only. Na? Sir, why we have to apply some energy means because of in between the nucleus and outermost orbital we have attractions. Okay, in between the nucleus and outermost orbital we have some attraction. To overcome that attraction, we have to apply some energy. That energy only we can call as a ionization enthalpy. Okay, the minimum amount of energy is required to remove an electron from the neutral gaseous atom is called as a ionization enthalpy. So this we are going to represent like this also. Okay, we are writing as a we are taking as some neutral atom. What is a neutral atom? Neutral atom can be represented with X. Okay, so gaseous atom. Okay, so when X is by losing of the electron, it forms as a unique positive ion. By losing of one electron, it forms as a unique positive ion. To remove the one electron, whatever the energy it is there, whatever the energy is required, that we can call as a first ionization enthalpy. Okay, and we have a second ionization enthalpy also. Sir, what is mean by the second ionization enthalpy means more amount of energy is required to remove one more electron from the unique positive ion to form as a di-positive ion is called as a second ionization enthalpy. Okay, the amount of energy is required to remove one more electron from the unique positive ion to form as a di-positive ion is called as a second ionization enthalpy. Second ionization enthalpy can be represented with I2. So if you compare with the IE1, IE2, which one is having the greater the value means here IE2 is having the greater the value than that of the IE1. Second ionization enthalpy is greater than that of the first ionization enthalpy. Okay, here in daily level, how they're asking the questions means here for different elements they are given some different values one, but all values we can't remember. All ionization enthalpy values it is not possible to remember. So due to that reason only we have to remember the concept. Sir, what is the concept means here? They had given some different values for the different elements. For example, X is there, Y is there, 5 Z is there. So first I'll give us some example here. So here X, Y, Z. Okay. So I'm taking as a 2 calories for the X. Okay. 5 calories for the Y. Okay. And 1 calorie for the Z. They're asking, write the increasing order of ionization enthalpies of the given elements. Right? The increasing order of ionization enthalpy of the given elements. So how we can write ma? Because of we know this one. We know the ionization potential value. Okay. Increasing order means least to highest only na. So which one is having the least value? Z. After that,
Z. Y.
Y. Y or
No,
X?
X.
X. After that, Y.
Y.
This kind of questions are there. Okay. So this kind of questions are there. Okay. Sir, what are the factors affecting the ionization enthalpy? Okay. So we can call as the first ionization enthalpy, second ionization enthalpy. Sir, what are the factors affecting the ionization enthalpy? Factors affecting ionization enthalpy. Okay, what are the factors means? First one is screening effect. This also we can call it as a shielding effect also. Screening or shielding. Okay, and size. Screening and size are inversely proportional to the ionization enthalpy. Okay, so screening effect and size are inversely proportional to the ionization enthalpy. So based on that one means here, poor shielding effect, greater the ionization enthalpy. So greater the shielding effect, lesser the ionization enthalpy. First of all, what is meant by the screening effect? What is meant by the screening effect? How many members you know? How many members you know? What is meant by the screening effect?
So the screening effect is where electrons from the inner shells block the nuclear charge from.
In my words, it is called as a protection.
Okay, yeah.
Okay, so it is called as a protection. So how you're calling as a protection means here. Okay, I think so. Everyone will have a favorite hero, favorite heroine also. Is it right? If suddenly they came in front of humans, we have a more curious to give shake hand. We have a more curious to take one photograph with them. Whether we are curious or not. We are curious or not. Samhita, Jay, Niharika. Are you curious or not to take some photographs, to take some autograph? Okay, if some favorite hero they came, or favorite heroine they came to your native places. Okay, so you are very curious, and because of you loved them. Okay, but if you want to approach to them means to get signature or photograph or something means here in between them and us, in between we have some other people also. Who's one? Who are present in between them and us? Who are there? We can call as a bodyguards, bouncers we can call. Have you seen or not? In TV, somewhere they are showing na. Is there or not? Okay, so bouncers are there. So outside, let's consider it as an electron. Electron is you, and nucleus is your favorite hero or heroine. Okay, in between the hero or heroine and you, some bouncers are there. Okay, if more number of bouncers are there means it is not possible to meet them. It is not possible to meet them. But if very less number it is there, it is very less number. For example, if only 2 members are there, if only 2 members are there around them, if only 2 members means easily we can approach to them na. Easily we can approach to them. Yeah. So easily we can approach to them means what happened? It has a strong attractions. While having the strong attraction, if you want to remove this one, if they want to throw you outside, so they have to put more energy only na. So when you are having the high ionization enthalpy means Greater the screening effect here. Okay, smaller the screening effect, lesser the screening effect, poor shielding effect, that time ionization enthalpy will be more. Okay, at the same time, some 6 members are surrounded to that person. Some 6 members, that time we are unable to reach them also. That time we are unable to reach easily somebody, they can drag us or they can pull us here. Okay, so easily they can pull. At that time, what happened? Greater the shielding effect, lesser the ionization enthalpy. So that's why what we can say means here, screening effect is inversely proportional to the ionization enthalpy. And size also, greater the size, lesser the attraction forces. Easily we can remove the electron. Smaller the size, greater the attraction forces. It is very difficult to remove the electron. That's why it is not possible. Okay, that is the thing. And what is another factors we are having means here? One is penetration power. Sir, penetration power is applicable for s orbital, and p orbital, and d orbital, and f orbital, which are having the greater the penetration power means s orbital, p orbital, d orbital, f orbital. Okay, why the s orbital is having the greater the penetration power means s orbital is having spherical shape. It is very in all the directions. It is very close to the nucleus. So due to that reason only s orbital is having greater the penetration power. Okay, and according to the electronic configuration. Electronic configuration. Electronic configuration means here halfly filled orbitals. Halfly filled orbitals and completely filled orbitals. Completely filled orbitals are more stable. Completely filled orbitals are more stable. So whenever here for this one, based on that one question I'll ask you. Okay, so how they'll ask means a question, they give us a second period element. Lithium, beryllium, magnesium, sorry, it's not the magnesium. No. Beryllium, boron, after that, boron, carbon, nitrogen. Let us see, nitrogen, oxygen is there. Generally, all are belongs to the second period elements only, na? Lithium, beryllium, boron, carbon, nitrogen, oxygen. All are second period elements or not? Across the period, ionization enthalpy is going to be increases. Across the period, ionization enthalpy it has to be increased. That means from lithium to oxygen, it has to be increased. But it is not increases. We have some exception case. Sir, why it is not increases means here from lithium to beryllium, it is going to be increases only. If you compare the beryllium and boron, we have a different ionization enthalpy. Sir, what is the correct order? What is the correct order means here? So here and here. Right. Now we can check it out. In these two places. So in these two places, beryllium is having greater the ionization enthalpy than that of the boron. If you compare with the nitrogen and oxygen, which one is having the greater the ionization enthalpy means here, nitrogen is having the greater the ionization enthalpy. Sir, why the nitrogen is having the greater the ionization enthalpy means based on the electronic configuration. Here what happened? NS2, NP3. This will get us NS2, NP1. Here you will get us here NS2. This one NS2, NP1. According to the condition, halfly filled orbitals and completely filled orbitals are more stable. In that, completely filled orbitals are more stable than that of the halfly filled orbital. Okay, according to that. Now, once you checked out beryllium, the maximum number of electrons present in s orbital is equal to 2 only, na? If it is having 2 means it is completely filled. So that's why beryllium is to remove the electron from the beryllium, more energy is required than that of the boron. Sir, in this case, while comparing the nitrogen and oxygen is having smaller the size only, na? But oxygen it has to be greater the ionization enthalpy. But you wrote as a nitrogen. Why you wrote as a nitrogen means here because of nitrogen is halfly filled. The maximum number of electrons present in p orbital is equal to 6. But in electronic configuration, how many p electrons are there? 3 electrons are there. But here, NS2, NP4, NS2, NP4. So this one is halfly filled orbital. Due to the presence of the half-free filled orbital, it is having high ionization enthalpy. So this one is first ionization enthalpy. We can have a second ionization enthalpy also. Based on this one, they're asking, what is the second ionization enthalpy of the second period element? Can you guess? I'm writing the answer is Li is less than beryllium. Beryllium is less than boron. Boron is greater than carbon. After that, nitrogen. Nitrogen is less than oxygen. So this is the order of second ionization enthalpy. Same concept. After removal of the one electron, here you will get as a NS2 configuration. In this one, you will get as a NS2 NP3. Okay, same concept here. That concept only I applied. This is the previous year question also. Once you check it out. Okay, so this kind of questions are there based on the ionization enthalpy. Okay, and electronegativity. What is meant by the electronegativity? Means here the tendency of gaining of electron towards itself is called as a electronegativity. Okay, down the group, electronegativity is going to be decreases. Across the period, electronegativity is going to be increases. So we have some periodic properties. One we can call, we had seen as ionization enthalpy, electronegativity, electropositivity, electron gain enthalpy. Here, electron gain enthalpy and ionization enthalpy, I'll write as a side by side. Electron affinity or electron gain enthalpy. Let us see. First, we already seen ionization enthalpy down the group. So down the group, that means we can write as a groups here. Group, and this one is here periods. So down the group. So ionization enthalpy is going to be decreases only now. Across the period, ionization enthalpy is going to be increases. Similarly, electron negativity also down the group it is going to be decreases. Across the period, it is going to be increases. Electron affinity value. Electron affinity value also it is down the group, it is going to be decreases. Across the period is going to be increases. Electropositive character. Electropositive character is down the group is going to be increases. Across the period is going to be decreases. So this is the common concepts here. Sir, what is mean by the electronegativity? What is mean by the electronegativity means here the tendency of gaining of electron towards itself is called as a electronegativity. Okay, sir, electronegativity also we can calculate from the ionization enthalpy and electron affinity. How we can write means here electronegativity is it is the average of ionization enthalpy and electron affinity by 2 also, because we have different units. Based on different units, we have a different formulas also. In place of 2, we can write as a 5.6 and we can write as a 554 also. 5.6 when we can write means electron volts. 554 means joules. 2 means here it is calories. Okay, so based on that one, we can write as a different formulas, but formula is same only. Okay, so which element is having highest electronegative atom in the whole periodic table means fluorine. Fluorine electronegativity is 4. Now we got the clarity. That's why fluorine it always be exhibit as a negative oxidation number. It never be exhibit as a positive oxidation number. Okay. Now, electron affinity. What is meant by the electron affinity means electron affinity is exactly opposite to the ionization enthalpy. Okay, electron affinity is exactly opposite to the ionization enthalpy. Okay, and electron affinity is nothing but the amount of heat energy is releases when an electron is added to the neutral gaseous atom is called as a electron affinity value. Clear? First electron affinity is always be exothermic. Second electron affinity is always be endothermic. Okay, and electropositive character. The tendency of losing of electrons is called as a electropositive character. That is only we can call as a metallic character also. Down the group, metallic character is going to be increases. Why means electropositive character. Electropositive character is depends upon the ionization enthalpy. Lesser the ionization enthalpy, greater the tendency to lose the electrons. So this is about here some periodic table. So based on this one, I'm going to forward some questions, ma'am. I'm going to include the test. Okay, whatever the questions I'm going to be enter into the test, all those are previous. Previous year question means here, January you wrote the JEE exam, na? In JEE exam, what are the questions they asked in the month of January, Jan 2024? That questions I'm uploading in the question paper schedule. So can you practice all that questions here tomorrow? Okay. So we'll continue in the next class. Thank you all.
Thank you, sir.
Yeah, Harika is very fast.